Have you ever wondered how a single computer can shout a message and have every single other device on the network hear it all at the same time? Well, it's not magic. It's actually a fundamental piece of network engineering called a broadcast address. And we're going to break it all down. So that's the big question, right? How does this even work? You've definitely seen it in action, probably without even realizing it. You know, when your computer first hops on a network and needs to find a server, or maybe when an announcement goes out across an entire office, there has to be a way for one device to talk to all of them. And the answer is something called a broadcast address. Okay, let's dive right into this. First, we'll talk about the fun part, what it means to shout on a network. Then we'll see how that compares to the other ways computers can talk to each other. We're even going to get our hands a little dirty and calculate a broadcast address ourselves. After that, we'll look beyond IP addresses. And finally, we'll check out why the future of networking is moving in a whole new direction. Right, so imagine you're at a super crowded party and you need to get everybody's attention at once. You're not going to go around whispering in each person's ear, are you? No way! You're going to stand on a chair and shout so everyone can hear you. Well, in the world of computer networks, that shout has a very specific name and a very special address. So here's the official definition. A broadcast address is basically a special destination that acts as a universal to-field. Think of it like the network's emergency broadcast system. When a data packet gets sent to this address, the network hardware itself makes sure it gets delivered to every single device on that local network. No exceptions. It's the ultimate public announcement system for computers. But here's the thing. Shouting isn't always the best way to communicate, is it? Networks are actually pretty smart, and they have different ways of talking depending on what you're trying to do. It really all boils down to a simple question. Are you trying to have a private conversation with just one device, a group chat with a few, or a public announcement to absolutely everyone? And this table just lays it out perfectly. You've got unicast, which is like a one-on-one private conversation. Then there's multicast, which is basically a group text. Only the people who are part of that group get the message. And then, of course, there's broadcast, our party crasher, shouting its message to everyone, whether they want to listen or not. So if a computer wants to send out a broadcast, how does it know where to send it? It's not just some random number. It's a very carefully calculated address. Let's pull back the curtain and see exactly how it's done in the protocol most of us use every day, Internet Protocol version 4, or IPv4. Now, to crack the code of the broadcast address, we really only need two things: any IP address that's on the network and its trusty sidekick, the subnet mask. These two pieces of information are the keys to the kingdom. And don't worry, the process is way simpler than it sounds. It's really just 4 little steps. We take our network IP and the subnet mask, we do a quick flip on that mask, and then we put them together with a little binary magic. Let's just walk through a real example, and you'll see exactly what I mean. Okay, so let's start with our network address, 172.16.0.0. In binary, it looks like this. Now, pay close attention to the part in bold. That's what's known as the host portion of the address. You can think of it like the street number on your house. It's the part that's unique to each device on the network, and it's the only part we're going to mess with. Next up, the subnet mask. In our case, it's 255.240.0.0. The mask is like a stencil. It tells us which part of the IP address is the network part and which part is for the hosts. All the ones in the mask cover up the network part, and all the zeros leave the host part exposed, ready for us to work our magic. All right, step 3 is where it gets fun. We're going to flip the subnet mask completely on its head. Every 1 becomes a 0, and every 0 becomes a 1. What this does is it creates a perfect template of just the host portion of the address. It's kind of like a secret decoder ring that lets us modify only the host bits. And now for the grand finale. We perform what's called a bitwise OR operation between our original network IP and that inverted mask we just made. And what's the result? Bam! Every single bit in that host portion is flipped to a 1, giving us our broadcast address, 172.31.255.255. This new address is the king of the subnet, it's the highest possible address, and it's reserved for one thing and one thing only: broadcasting. So we've seen how broadcasting works with IP addresses, which is all well and good. But what if I told you that this whole concept goes even deeper? What if broadcasting is built into the very hardware that makes our networks actually work? Let's peel back another layer of this networking onion and look at something called the data link layer. This is where the rubber really meets the road, where technologies like Ethernet are handling the physical sending of data. And just like at the IP layer, it needs a way to shout to everyone on the local wire. And this right here is the hardware version of a broadcast. Every network card has its own unique MAC address, right? But this special address, all Fs, is the universal all call. When a data frame is sent to this destination, every single device on the local network gets it and has to process it. This is used by super important protocols like ARP, which is kind of like the network's town crier shouting, "Hey, who has this IP address? I need your MAC address." For decades, broadcasting has been the king of one-to-many communication. But, as our networks have gotten way bigger and way more complex, the king's voice has started to get a little hoarse. All that shouting has become less efficient. And so the designers of the next generation of the internet decided it was time for a revolution. Get ready for this one. IPv6, the protocol that is literally powering the future of the internet, has completely and totally thrown out the concept of a broadcast address. Gone. It decided there was a much smarter, a much more elegant way to handle this kind of one-to-many communication. See, instead of shouting, IPv6 uses multicast for pretty much everything. And honestly, it's a total game changer. It is so much more efficient. Instead of forcing every single device on the network to stop what it's doing to listen to a broadcast, devices can just join specific multicast groups they're interested in. It's like going from that noisy, crowded party to a quiet, intimate gathering with just your closest friends. It dramatically cuts down on network noise and lets devices just ignore traffic that isn't for them. And that really brings us to our final thought here. This move from broadcast to multicast, it's a sign of the times. It's a shift away from these blunt, one-size-fits-all tools to more intelligent, more efficient, and more targeted methods. It really makes you wonder, doesn't it? What other digital shouts in our lives are going to be replaced by polite group texts in the future? And what's that going to mean for the way we all communicate and connect?